impressive. Yeah, just 1 second. Hello. Oh, feel like I'm gonna sneeze. No. Sure. Oh, okay. This is not working so well. Oh, and now I unplugged it from my computer. Thanks. One second. Sorry, just 1 second. All right, looks like most people are here. So we're going to continue this morning with a little bit of animations. We're right at the end of covering what we were hoping to cover for animations, but didn't quite make it all the way there. And then we'll move on to gestures, and you'll see that they're very related to each other. So it's important to have the understanding of animations before moving on. You might want to close that door in the back. Evan, can you close the door to the other room back there? Oh yeah, and the one in the back over there. All right. So we saw how to do an animation in response to a scroll event using animated event, and how to use native driver along with that so that we're not bound to the JavaScript thread and having to call back in on every event in order to update the animated value. And so we're going to take that knowledge and apply it to gestures really shortly. But before we do that, I just want to make sure that we're all kind of on the same page, or we have at least some shared basic level of understanding for animations, and want us to build a modal component. So what it should do is just animate in, so you can add a button somewhere, tap on a button, it animates in some content. It would have some overlay that's like a black kind of background or white or whatever you want. And and you should be able to then hide that. And it should animate in somehow and animate out somehow. And I could show you an example if we open this up. What did I run in here? So one way you could do this is have something that looks kind of like this, where don't worry about the gesture for now, we'll get to that later, but you can click on it and it fades in, and then when you press somewhere else, it fades out. It could just be a simple button. This thing isn't starting, but there's an example in the React Europe Animations Gestures repository that I put on the reactu.xyz website. And so if you're kind of not sure what to do, you can have a look at the modals example there and go from there. We're just going to spend 20 minutes now. I'm going to walk around and make sure everyone's kind of caught up there, and then we'll move on. Here we go. We have this. So let's. So you can make something like this. All right? So if you know what you're doing or you think you can figure it out, keep doing it. But if you're totally lost, I'm just going to build this right up here in Snack, and I'll talk about it as I'm going. But it's definitely more valuable if you try building it yourself, if you think you are able to do that right now. So all I've done so far, I've created a new snack and I've imported animated and a button. I'm just going to add a placeholder for this thing. Say open a modal. Now let's just say this dot open modal. And I'm going to make a component called modal, where right now all it's going to do is return the children and wrap this in a modal. So I know I need to have some state that indicates whether the modal is open or not. So is modal open, let's say. It starts as false. This open modal function is just going to do this dot set state. Modal is open true. And we'll pass that into the modal as just some visible prop. Is modal open? And the most basic way to do this now is visible. All right. So, what have I done here? Is modal open? Visible. This dot state dot is modal open. Set props dot visible. Oh, thanks. Is modal open? There we go. So, of course, this isn't a modal at this point. It's not really much of anything, but we now kind of have something we can work with here to start adding an animation to it. So, let's go up here, and we're going to first. Let's just make this appear on top of everything. So we can do style sheet. So you may be familiar with the style sheet absolute fill shortcut. Basically that is just position absolute, top 0, left 0, right 0, bottom 0. It's just a shortcut for having to type all of that. And it will position it on top of all of the content. I'm going to move this down here actually so it is on top of the button. You might remember if you've used React Native much, which hopefully you have at this point, that the concept of Z-index is not really the same as on the web. I generally recommend not using it and instead just depending on the order of siblings. So the Z-index. The behavior is different on iOS and Android, and it doesn't work how you'd expect it to work on the web. So generally, I just don't use it, and instead, the order of the siblings will determine the stacking order. So button comes before modal, so modal is on top of the button if they're both absolutely positioned. So, yeah.
Is that absolute fill? Do we need to add like flex or something?
No. Yeah, so the question was, do you need to add flex or something to absolute fill? No, it's just, right, so this is position, absolute, top 0, left 0, bottom 0, right 0, which is, just makes it take up the full screen, or the full size of the container that it's in. In this case, that's the full screen. I'm going to make this an animated view, and an animated view, and let's give this a background. So I'm going to have another animated view, which is also absolute fill, and I'll give it like background color of something like that. Sure. Okay. So that's good. We need to have now yet another one of these. Although in this case, we could actually do flex. And sure, I'm just going to align it to the center. And this is unreachable code, so we'll just remove that. So it's aligned to the center, justified to the center. Set the background color here. Right, so that would, if we just use the full screen background color white, it would just show up on top of everything. But that's not really what we want with this modal, so I'm just going to leave that for now. And so we kind of have our sort of scaffolding for what we need here, right? We have a view that is positioned on top of everything. Within that, we have another view that takes up the full screen and has some background color that is translucent. And then we have another view that sits on top of that that holds the content. So let's adjust this a little bit so we can actually see it as like a box inside of here. So we can say padding 30, background color, let's make it white. All right, so that kind of looks like a modal. And we can add a button to it. That was not intentional. This dot set state. Thank you. And there we go. So we don't actually want this inside of the paragraph. My bad. That is what we want. So before we continue and actually add this animation to it, just to recap, we have a modal component that receives a prop called visible, toggles between true and false depending on whether it's visible. If it's visible, we should render the content on top of the other content in this container. And when we close the modal, it should animate out and disappear. So to do that, we now need to create a, well, actually, let's not use state for that. Let's use an animated value here. So I'm just going to call this value, new animated.value 0. Actually, I'm going to do this in the constructor because it's possible that we'll initialize it as being open. So I want to do this dot values, new animated value, props.visible. So we'll initialize it as visible or not. And now we can bind the opacity on this entire thing to this dot value. Okay, so if I change this to is modal open true, right, it's visible, and otherwise it's not visible. But we didn't actually do anything. Like if we press this button, well, first of all, actually we need to do one thing. But if, well, we need to set pointer events on it. So right now this is all rendered on top of everything, and so we can't, it's still there, but we can't actually click through it. So we need to set pointer events, which is the same thing as in the browser. If you want to be able to click through the view, you set it to none. Otherwise, you just set it to auto. Stop props, stop visible. Right. So if we click on it, still it doesn't do anything. And that's because we're not actually changing this value at any point. So because we can't use component will receive props anymore with React 16 to do side effects, we're going to do that in component did update. So we can take the prev props and say if this.props.visible and not prev props.visible. Now we need to animate it to be visible. Else if this, not this.props.visible and prev props. Yeah, you're not supposed to have any side effects, and component will receive props. It should just be a pure function. So the question was, is this a recommended way of doing it now that there's well, I mean, you can polyfill, component will receive props, but you're not supposed to use that for side effects. There's this static function get derived state for props, I believe it's called, which is, it shouldn't have access to any, like you wouldn't even be able to access this animated value from that static property or from that static function. And so you have no way to animate it anyways. And so that's why, sorry? Yeah, did update, you can do side effects there. So we can now do animated spring, this dot value to value. And we're saying that 1 is visible. It's kind of arbitrary, but also it just sort of makes sense for 1 to be visible and 0 to be not. You can do whatever you like there. So we're springing this dot value to 1 when the prop visible is currently true and the previous value of the visible prop was false. And otherwise, we're going to go to 0. Right. So that's pretty much how you can build a modal. In the example that I provided, we did other things like we animated the translate Y. I think hopefully by now everyone's familiar with how to do that by using interpolate. But because that was yesterday, I'm going to quickly demonstrate that again, just to refresh people's memory, and then we will move on. So I'm going to interpolate. In fact, yeah, let's do it here. I'm going to interpolate the translate Y from the value with an output range of, let's see, do we want it to slide down or slide up? Let's say we're going to slide it down. So it's going to start at a negative translate Y, and then we'll animate it to 0. And we're actually, in this case, now going to make this wrapper an animated view also, and just set the translate Y on that, like so. There we go. Cool. All right, do we have any questions about that before we move on? I think it's just using, there are a few things that maybe people weren't familiar with about React Native and how to position views and how to put things on top of other things and that kind of stuff. But generally, it's no different from what we did yesterday about animating a box. I guess in this case, we're using a component that handles the animation for us based on a prop, and then doing the animation in component did update. That's something that we didn't see yesterday. Let me know if you have any questions about that. The rest of it is identical to animating the box, spinning it, translating it, animating the opacity. It's all the same.
When you're starting component updates, you might be starting simultaneous animated spring. So when you're binding that to a value, does it cancel automatically when you're starting new ones?
Yeah, so the question was, in component did update, you might, I guess you maybe have an animation running already, or something.
You already have one, right? The
Yeah.
same value.
Sure.
While the modal is sliding
Sure.
down, you might click to close. Well, technically.
Yeah, so it's a really nice thing with animated is it just handles it for you. It animates from whatever value it's currently at to the value that you're sending it to.
Or pause, and then it starts towards the next one.
Exactly, yeah. So if it's at 0.5 when you press close, then it just animates from 0.5 to 0.
Cool.
And just for fun, let's use native driver. And we have to add it to both of these in that case. Okay, so now this is happening on the UI thread and only calling it to JavaScript when it first handles this event and doing this initial reconciliation in order to update the visible prop. After that, the whole animation's running on the UI thread. Okay, so this stuff, good? Great, let's move on then. I'll actually save this and post it in the channel because maybe it's slightly different. I don't have Slack open. I'll post it later. Okay. So the last thing to cover, I think it's something that people don't talk about enough when they introduce concepts, is what are the limitations of using this API. So animated is not particularly good at doing exit animations because you kind of have to keep the component around until the animation is complete. You have to manually manage not unmounting the component. And so maybe you have to wrap the component in this other thing that says, okay, this has been unmounted, or someone wants to unmount this, and so I should now start this animation, and when this is done, we can call back and say, okay, now you can unmount this, or basically you have to do some kind of state management on your own that adds this extra layer there for you. Things like React Motion are a little bit better at that. They handle it for you. That's kind of like the main use case for React Motion, and Transition Group was another one. Does that exist still? It doesn't work with React Native, but another limitation is, of course, the limited set of properties available to native driver. So you can't animate like width and height, and currently you can't animate color and background color. Again, those color and background color are things that can change. That just needs to be implemented, but currently it's not implemented. So yeah. Another limitation, I guess I just added this because it does kind of come up sometimes, in that if you're doing animations on the web, you're probably not using animated because not many people do that for whatever reason. I think it's also a good API to use on the web, but you just might not have that in a web code base that you're working on. People might not have added it there, and they don't want to increase the bundle size or whatever, and so it just might not be a tool that you can use on both platforms necessarily. So something to keep in mind. Okay, let's take like a 5-minute break really quickly. I know we just started, but just because we talked about a lot of stuff, and we're going to talk about gestures for a while, and I don't want to take a break in the middle of that. So just grab some water, coffee, or whatever, and we'll come back here in 5 minutes and talk about gestures. Sorry? Oh yeah, I'll do that right now. Yeah, I just didn't have Slack open. The same example is already in the animations and gestures repo, basically. It's just maybe slightly different. different amounts of shadows. So if you just try it on like a normal view and you set elevation 1 and then 2 and 3 and 4, you'll notice the shadow becomes bigger. It's like a material design thing. Yeah. Yeah.
The comparison with the if statement that you're doing the component is update, like this prop is and negative per cross, is because you always you're just checking that it's different.
Yeah. The only conditions that I care about there are, is it currently visible and was it previously not visible? Or,
What I'm getting.
yeah. Although in this case, that's the only prop that's passed in. So I guess it doesn't really matter as much. All right. So this next topic, gestures, is, I think, really interesting. There have been a lot of developments in the last year in React Native on the topic of gestures. We're going to talk a little bit about the gesture system that's built into React Native and what kind of some of the problems and limitations are. And this has been primarily what people have used since React Native was first released until now. Most people still use it. And then we're going to talk about this library called React Native Gesture Handler, which is a far better way to do most gestures, in my opinion at least, and hopefully you'll see why that is. So first thing we're going to talk about is this thing called the JavaScript Responder. So this is essentially how gestures are performed in React Native and core React Native. When you create a new project and you add a touchable opacity or whatever, you're using the JavaScript Responder system under the hood. And so the way that works is that the main thread or the UI thread, which is where your native app traditionally is running, and that's where gesture events arrive. That's where we were talking about before, doing like animations that we're offloading from the JavaScript thread to elsewhere. That's to the main thread. So this is where events arrive. When you touch the screen, an event is dispatched, it's received on the main thread, and from there, what React Native does is it kind of does some processing on that event, and then it dispatches it to the JavaScript thread. And the JavaScript thread then has to handle determining what component does this, like, is there something that is handling this stream of touch events? Is there a component that's going to be the responder for this touch, or not, or is it even a valid gesture or whatever? That is delegated to the JavaScript thread. So you can kind of visualize it like this, right? You touch on the screen, a touchdown event comes in, it's processed, and then this dotted line shows it kind of being sent over to the JavaScript thread where this React component hierarchy exists, and there's a system in place in React Native for determining how this kind of makes its way through the hierarchy. We're not going to talk about that too much. It's not particularly useful to know, I would say, but just this general model of knowing that the touch events arrive on the UI thread and then are kind of handled on the JavaScript thread and responded to on the JavaScript thread is kind of the main takeaway from this. So we can jump right from there to saying, what's wrong with this? So the first thing is that you need to call back into JavaScript on every frame of an animation or on every frame of a gesture. So anytime you have a touch event, so we saw before, like touch down, touch move, and up, anytime that you move your finger, we need to dispatch that event to the JavaScript thread. The JavaScript thread has to find who's responsible for it. Maybe there's already a designated responder because one of the components has handled it. Has to have that component then execute some code that responds to the event and maybe updates an animated value or does whatever it's going to do in response to the touch event. It then has to recompute some state and send that back over to the UI thread, and then the UI thread updates itself according to what was just provided to it. And this is very similar to what we discussed with animations before without the native driver. Every time that you, so when you run like a spring animation, every frame, an event will be fired from native saying, hey, there's a new frame. The JavaScript thread will then take that new time and recalculate what the value should be for an animated value, and then recalculate all of the style props that, or other animated props that are derived from that, and then send these new values over back to the UI thread. And as we saw before, when the problems here arise when the JavaScript thread is busy, whether because maybe you're doing some reconciliation or something is happening on that thread that prevents it from executing any other incoming events or incoming code for some period of time, you're basically just unable to maintain 60 frames per second as a result of that. And there's really no getting around with this with the JS responder system, because all of the logic for handling the events and all the logic for even determining who is the appropriate component for handling the event all lives in JavaScript. So this is a huge limitation of this system. So we can kind of visualize that here. This is using something called Pan Responder, which is built on top of the JavaScript responder system. It gives you kind of an abstraction where you don't have to handle the lowest level touch events, but it can more easily recognize pan gestures, which are just when you're moving your finger left to right, up, down, etc. And so we're able to build something like this, which, I mean, when you just have a box on the screen by itself, and this is the only thing that the application is executing, you're totally fine doing this with Pan Responder. You're not going to have any issues. But let's say we were to simulate some more complex stuff happening in your application at the same time. So here I press the button to block the JavaScript thread for like a couple of seconds and you can't do anything. And now here I'm blocking it intermittently. So like every few hundred milliseconds I block it for a few hundred milliseconds. And you can see that like as I move my finger, nothing happens and then it jumps to where my finger is. And you know, that's just not really an ideal way for gestures to work on it. So the question was, how are you blocking the thread? There's some examples in the repo that I put up, but basically you can just do like a while loop. Just a while loop, and then once however many milliseconds have passed, then stop the while loop is the easiest way to do that. So another issue is that the negotiation of who becomes the responder, who are the components or the component responsible for handling the touch events. The process for that isn't predictable when you have some logic split between the UI thread and the JavaScript thread for handling gestures. And so I mentioned before the JS responder is how things like touchable work and how like Pan Responder works. But for example, scroll view component is not re-implemented using the JavaScript responder system. That is just a bridged native component that has all of the native gesture handling logic around it. And so that happens on its own on the UI thread, which is how we're even able to make that, that example that we did yesterday of scrolling and animating a header in, animating the opacity as we scroll, and having that be resilient to the JavaScript thread blocking, is that this gesture lives on the UI thread. And so what we end up with is we have these two gesture systems. We have the JavaScript responder and we have the native gesture system. And these events come in and they're kind of handling these events in parallel. And it's possible for something to recognize on the JavaScript thread and on the UI thread. And now you have these two things happening at the same time, and you don't have a good way to kind of negotiate and specify like under what conditions one thing should recognize and another thing should not if they live on these separate places. And we'll look at a concrete example of that. So here's an example from Christoph Majera's talk. This is, I highly recommend watching his talk from React Amsterdam, where he goes over all of this as well. And it never hurts to hear it many times from different perspectives to kind of absorb it a bit more. But here's one case where it's a very common case that I'm sure if you've built a substantial or even small React Native app, you've probably noticed it pretty quick, where if you have a scroll view and you have a touchable component inside of the scroll view, so maybe touchable opacity or highlight, and you start scrolling, but your finger starts on like one of the touchable components, and it highlights that component or has the touchable effect on it, even though you've started scrolling. And so what happens is that because you've placed your finger there, the touch event goes and goes, okay, well, there's a touch in on this component, so clearly I should recognize on the JavaScript thread. But as the scroll starts happening on the UI thread, now it has to say, okay, well, we've recognized that the scroll view is now occurring, that this gesture is now occurring. And so it has to tell the JavaScript responder to cancel any recognizers that are active at the moment. And that's basically the problem, is that what should be happening is that the touchable inside of the scroll view should wait for the scroll view to fail to recognize, or give it some time to potentially handle a scroll event. But it just doesn't do that because they have no way of communicating with each other. And that's visualized here by having these two black boxes, right? As far as they're concerned, the other thing, sure, maybe it exists, but there's no communication channel between them, except you can send a cancel event from one to the other, or a common workaround for this next problem I'll show you is another way. So this is kind of what it looks like if we look at that Qua app. So notice how on the left, if I scroll, like as soon as I touch, it starts highlighting the view. And on the right, like I really have to linger on it and do something that much more closely resembles an actual intent to tap on that view. So it's a small thing, but definitely you notice it when you're using an app and it doesn't have the expected behavior, and it highlights things really easily as you're scrolling. And there are other potential problems that can arise from this that actually impact usability of your app as well. Another common issue that occurs with this is when you have like a pan gesture inside of a scroll view. So in this case, so I mentioned before that you have this touch and then you start scrolling, and so the UI thread, right, the scroll view recognizes, and on the JS thread this other thing has began, but it hasn't become active yet, and so it becomes canceled. But in this case, it's possible for both the scroll view and the pan responder to be active at the same time. And it's best to just like visualize it, like seeing it in action. So if I start dragging this, and now I'm like scrolling, like it's canceled at this point, but like it shouldn't even give the opportunity for the scroll view to still be in a state where it can recognize this gesture. If I've started moving this box to the left or right, and then I move my finger up or down, that means that we haven't even communicated to the gesture recognizer on the UI thread that, hey, we've already picked up this event and we're already moving this thing, and it's become the handler for this gesture, so don't worry about it. You're like, don't even have a chance to match this anymore. And a common workaround for this, which is extremely strange and unfortunate, is to, once you start recognizing this pan gesture inside of a scroll view, you do some like set state to set scroll enabled to false on the scroll view, just so that it's not possible for it to recognize. If that doesn't make you like feel gross by doing it, then probably you have a very good tolerance for weird programming techniques. Yeah, it is JavaScript, but it doesn't have to be that bad. Another limitation with the JavaScript Responder system and how it's kind of implemented in React Native is that there's the only abstraction that's implemented on top of it, aside from these touchables. So you have like buttons like touchable opacity and whatever, as I mentioned before. The only thing beyond that is pan. So you don't get like rotation or pinch or like fling gestures or anything like that. And so you kind of have to try and implement that yourself. And in the best case, you get something that is going to maybe closely approximate the native version of it, but also drop frames frequently, as you saw when the JavaScript read blocks for some period of time. So it's really not an ideal situation. It's also not composable. You kind of have these responders that are sort of also black boxes. Like you can't just make a component that says, okay, I'm going to wait until this other gesture recognizes, or I'm going to wait until this other gesture fails by not moving this much in this direction, or whatever. Various kind of like interactions between gesture. We'll see more about that later, but ultimately what people end up with when they're working with Pan Responder and the JS Responder system is basically like a massive component that handles various types of gestures in one place, and it's like hundreds of lines of code of being like, okay, if this touch event happens and the position X is this, and the previous position X was this, and this thing is now whatever, and it's just this really long thing that you kind of have to, it's super manual, and there's no really solid way to build abstractions on it. And the last problem I want to highlight is that there isn't any API to define how native views interact with each other. So it's best to look at some examples for that. So let's just pause this. Go back. Pause that one, pause that one. So if we look at the one on the left side, this is on Android. We have a drawer layout component, and inside of that we have a slider. And if I touch on top of the slider and start dragging to the left, it's going to start dismissing the drawer layout. But that's not what we want here. We want that to now jump the position of the slider, I don't know, the little circle thing, I forget what that's called, and initiate that gesture. But this isn't something that's built into Android. When you put these components inside of each other, it doesn't automatically say, okay, well, clearly this is what you want to do. You have to actually specify that behavior. And there's just not a way to specify that in React Native with the JS Responder system or any other APIs built into React Native.
Are you sure this isn't just an anti-pattern to get a higher rating?
Yeah, and the question is this not an anti-pattern to get a higher rating? Maybe it is. I guess you can only swipe to the right in this case. Yeah, so this is, it's something that comes up frequently in React Native apps. You'll have these kind of gestures, and you kind of just hit a dead end because there's really nothing you can do beyond writing another native component that handles this for you. It's just not built into the framework. Let's go back again. So another case where this comes up is, let's say you have a drawer layout inside of a view pager. And so you get to the last page, and you swipe to open the drawer on the right. And now you want to dismiss it by swiping from the left to right to dismiss the drawer. But the view pager now scrolls to the previous page. And you have no way of telling it that you don't want it to do that when the drawer is open. You want to be able to dismiss this drawer instead. And so it's not possible to do that with React Native Core. And so you can try and kind of invert that. And so you can put the view pager inside of the drawer. But then you have this other problem where now you can no longer swipe to the right to the next page in the drawer. So what do? And this is definitely a big source of frustration when making React Native apps. Of course, there are some cases where you'd still use a JavaScript responder potentially. So if you need to handle a touch event in JavaScript, there's complex logic that you cannot express using this tool that we'll look at next. Then you might need to use something like pan responder for you. Or we'll talk more about limitations of React Native gesture handler later, but if you run into one of those limitations, you could potentially use this as well. Do we have any questions about the JavaScript responder system and that kind of stuff before we move on to talking about React Native gesture handler? Are the problems that I mentioned familiar to anybody here? Like, have you run into any of those problems? Yeah, a decent amount, a few people. Okay, so React Native gesture handler. So what this gives you is gesture recognition on the UI thread, and it integrates with animated events and the native driver, so it doesn't need to call back into JavaScript on every frame. So as we saw again with animated before, with the scroll view and animated event with native driver, that is huge when it comes to guaranteeing that you have good frame rate. It plays nicely with other native components like scroll view. So when I showed the example of scrolling with a touchable, and it was highlighting every time I scrolled, and then on the right side I had the example of what it should look like, that was using buttons from React Native gesture handler. So it just knows how to properly behave within a scroll view and handle that interaction. It provides an API for defining how native components should interact with each other. So if you have a slider within a drawer, you're able to express that this slider should cancel other gestures when you start dragging it, and things like that. There are a bunch of gesture recognizers and handlers that are available just out of the box. So before you just had like basic touchables and pan. Using React Native gesture handler, you get tap, where you can specify any number of taps. So you could do like tap, double tap, whatever. There's long press, pan as well, pinch, rotate, fling. And these are some primitives that you can just use out of the box, and they're pretty easy to use, and we're actually going to look at most of these. And lastly, it's composable. So each gesture handler is a component. You can nest them within each other, specify the criteria for when one matches or doesn't match, specify whether one thing can run simultaneously with another thing, and stuff like that. So it gives you a lot more pleasant way to deal with gestures, not just in terms of ultimately getting a better result, but also the developer experience is a lot nicer. So the first things to look at are tap and long press. I think these are kind of the easiest, most basic things. In this video here, I tap on a button that says tap. And as you can see, as I move my finger outside of the button, it cancels. You can customize that behavior with the tap gesture handler. And long press, once you long press it for some period of time that you specify, it activates. So it kind of looks like this. You have tap gesture handler, number of taps. You don't have to specify it defaults to 1 if that's what you want. I just put it here for the case of making it explicit. And then we have this thing called on-handler state change, which we'll look at in a sec. And the behavior that you saw in the previous video of when I tap and then move my finger outside of the view, and then it canceled, that's what that prop does. So you can set that to false, and it won't cancel when you move outside. So on-handler state change is when you transition between any state within the gesture handler state. And so the first state that you start in for any gesture is in undetermined. So this is, you have the gesture sitting there, no touches happen, it's just completely inactive. It's the default initial state. Failed, we can look at that more later, but basically failed to recognize. Began is when you have touched the thing, but it doesn't have enough information yet to know whether it should activate or fail or not. And so it's still just waiting in a state of receiving more touch events, and from there it can determine whether it should activate. Canceled, it's possible for other gestures to say, to explicitly cancel other things, so we can also look at that one later. Not super important here. And active. Active is the one that you deal with most when working with React Native Gesture Handler. Usually you care when a gesture becomes active and when it goes from active to any other state. And often you don't really care what that state is, but it's just, was it active before and now is it not active? Or was it not active before and now is it active? And that's usually when you just do something. And then the last one is end. So that's when you like tap and release and it becomes active and then it transitions to end. So using this information, I'm going to just demonstrate how to make a button with tap gesture handler. And then we're going to have everyone try and do that as well on their own. So let's open this up on Snack. Just going to delete this other code here. So to use this on Snack, we actually import gesture handler from Expo. There are installation instructions. So actually the documentation is available at, oh, did I not? There we go. So, I mean, you could Google React Native Gesture Handler and find it, but kmajera.github.io/React Native Gesture Handler. Anyhow, that explains installation instructions inside of Expo and whatnot. So I'm going to get tap gesture handler from that. Oops, equals gesture handler. I'm going to delete this stuff. Delete this. And just add tap gesture handler. And we'll just add some set of view and some text that says no. The question was, does any of this work on web? And it does not at the moment. Sure. On state change, let's just stay. So for now, I'm just going to log this result of the handler state change. I'm just going to add a little bit of padding here. Background color. And let's open this up. Is this the right one? Let's make this. So we have this thing, tap on it, and get some logs. So the data that we get on this handler state change is that the old state was something 4. That's not so useful for us to know, but and then the current state is 5. We get various things like the x, the absolute x, target. Don't have to worry about too much. That's just the number that refers to the component that's the target of the gesture. And we'll talk about what the x and absolute x are and how they're different from each other when we get to pen, because that really doesn't matter so much for tap gestures. Yeah, so the question was the state and old state are enum, and that's correct. So we can pull this state property off of gesture handler, and let's just destructure this for convenience. And I'm going to get the old state and state off of the native event. And then we can just say if state equals state dot active, then do this. Right, so that does that thing. And that's essentially how we would handle this event. But it doesn't quite go all the way here to doing things like changing some property of the view. It doesn't like change the background color or things like that. And so to do that, we have to actually pay attention to the other events, right? All we've done here is say, if the state is now active, then do something. But what about if it has began, right? So began being, we started touching on this, but we didn't release yet, or we didn't like, you can, as I mentioned before, move outside of the view, and if it cancels, then it goes from began to canceled. And so there are kind of other cases that we need to handle here in order to be able to style the component in a result, in response to the gesture. But I just want to demonstrate as well, was it number of taps, I believe? Let's verify that. Yeah, number of taps is 2, let's say. So I tapped that twice. I guess you can't really see that, but double tap. Trust me, that's what I did. And okay, let's actually style this now. So we could say if state is so if it's began, we'll just set state and say touch is or touch began true. And if old state is began, or if old state is began and state isn't equal to, there's another way to phrase that. We can set state touch began false. And let's just set the opacity. And we have to set some state. And I feel like I might have a typo again. Yeah, there we go. Okay, in this case, I don't have should cancel when outside. Should cancel. Right, and so now it's moving from began to canceled, and so we update the state. If I double tap, we get that. Does anyone have any questions about this? Yeah.
If you've got this kind of system, why wouldn't you just use this instead of touchable without feedback or
Yeah, I would. So the question was, if you have this system, why would you not just use this instead of touchable without feedback and touchable opacity? I absolutely would use it instead of that everywhere, and that's what I do personally. This library has been under heavy development for the last year. The proper 1.0 release is probably, I suppose, going to happen tomorrow. So, but it's been used in production widely, and I absolutely would use it everywhere. Yeah. Vibrating on Android. I'm actually not sure about that. Yeah, you could add that if you wanted to, I suppose. But Yeah, it does the ripple effect automatically on Android. Not with the tap gesture handler. We'll look at some of the built-in button components that abstract over that for you and give you the same kind of touchable behavior that you get from touchable components. But we'll look at that shortly.
Okay, so in general, this is a better API for buttons and touchables?
Yeah, I would say so. Basically, based on the reasons that I just explained, there's some inherent problems with the JavaScript Responder system, and so I would use this instead.
Seems like with the touchable, things like that will end up being replaced by something like this, like
Yeah, so the comment was it seems like touchable would end up being replaced by something like this, and that was the original intention of this library was to upstream it and replace it, but it's kind of difficult at the moment to get big changes in upstream React Native, and so it might live alongside it for a while. All right, so let's do this exercise. You've seen how I've done it here, but it's very different when you actually try and do it on your own. So let's spend like 10 minutes trying to do this. I will share a link to this snack in the Slack, so you can just play with it if you want, or try and remake it and then jump back whenever you're unsure about how to do something. It's also a good way to do it. Yeah. Sure, 1 second. All right, how did that go? Any questions now that you've played with it a little bit? Got a spider web.
The documentation, I can see like the process, like the whole process and state, like began, then whatever, then fill.
Yeah, what other, I guess you're curious about like how it ends up in,
Like touch how the state changes.
you can also log it like,
On the change.
yeah, and just add logging and see kind of what happens as it happens. You will notice, and I'll talk about this in a minute about long press versus tap, how long press actually doesn't enter the began state. It just goes straight to active. And there's just some reasons for that.
Possible to combine the simulator with the Expo with the React Native debugger.
With React Native Debugger, yeah, I think they have instructions. I think, so the React Native Debugger, I guess, is that standalone thing, like Electron app or whatever. I think they have instructions in the documentation about how to set that up.
If we're using this like gesture handler to component, is there any fallback if we're doing like universal thing, or we need to check like it's just gonna fail?
I think this is kind of similar to what, so the question was, if you're using gesture handler and like a universal component, is there any fallback or is it just going to fail? So React Native gesture handler doesn't provide like a .web platform extension or anything like that. But I think Kurt mentioned this yesterday, if like when you're handling touch events, you should not do that inside of your universal components. They should just be static components. Or at least that's probably how you'll have the most reusability and success in doing it. But there's no reason why you couldn't potentially just implement a .web alternative for a lot of these things and map them to something else. If you are curious about that, there's a guy who's at the conference named Vincent Reimer, and he's investigating that, so he can chat with you. So we just talked about tap gesture handler. There's this property that's really useful with gestures that maybe a lot of you probably actually don't know about, even with React Native touchables without React Native gesture handler. And it does also work with React Native gesture handler. It's called hit slop. And what this does is, if you look how I'm tapping like way outside of that view, and it's not impacting the layout or anything, but I'm able to tap like pretty far above the view and to the side of it and still have it recognize this gesture. And this is how you're able to like have buttons that have a large enough touchable area where you can kind of fat finger your phone and be like, oh, I want to press that thing. And without being really precise with it, you can still actually have it recognize that. And so the way to do this is with something called hit slop. So to add this with React Native gesture handler, you should add hit slop to a view that is a child of the gesture. You can set hit slop directly on gesture handler components, but that only works if you set negative hit slop, so if you want to make it a smaller touch area, except on Android. But there are just some limitations that make that the case. And so in order to use hit slop with React Native gesture handler, just add it to the view, which is a child of your gesture handler. And so here I'm saying the hit slop has to the top of the view 50, to the left 100, to the right 100. And so if we had a square, which is a button that says tap, then, and that, what we see there includes like the padding and everything that's like the full layout of the button, then this dotted area around it indicates the touchable area of the view. And so if you use the touchable components in React Native and set hit swap on them, you can use the element inspector, and then there's a little button that's on, I guess depending on whether it's on the top or the bottom of your screen, the little info box, but there's a button that says touchables, and if you press on that, it'll actually show you something pretty similar to this. It'll show what the touchable area is for your touchable. Unfortunately, that doesn't actually integrate with React Native Gesture Handler right now, so that's one of the limitations at the moment in terms of being able to visualize what the touchable areas are for the components in your app. But still very useful, and you absolutely should use hit swap in lots of places to just make it more pleasant to interact with your app. And this is something I notice with a lot of React Native apps. People will kind of throw a touchable opacity somewhere or a touchable highlight and then not put a hit swap on it. And so you kind of have to like be really precise about where you're pressing on things, and it feels like something just doesn't feel right about how it's hard to press on things. And so in most native apps, people use hit swap a lot more liberally than people tend to do with React Native apps. So any questions about hit swap before we move on to long press gesture handler? So the question was, does it need to be defined in the direct child? Yeah, it does. Yeah. Mm-hmm. So the next gesture handler we'll look at is long press gesture handler. It's, as you can see, the API for these handlers looks kind of familiar between one and the other. It's, rather than being called tap, it's called long press. It's a component. It has a prop called onHandler state change, and in response to the handler state change, you initiate some action. In the documentation, there is a list of properties that are, I guess, props that are accepted by these different gesture handlers, and the one that we have here is min duration ms, and this is the default value for long press gesture handler. It basically says you need to long press for 500 milliseconds. So you need to tap and hold for half a second, and then it will recognize as a long press. But you can change that to whatever value you want. So let's do a quick exercise to just use long press gesture handler. But one thing I want to point out first is that the handler doesn't have a began state. So there's a distinction between discrete and continuous gestures that React Native Gesture Handler has largely tried to abstract over. And so discrete gestures pretty much go from nothing undetermined to active to ended, whereas continuous have a state where it enters began and active, and then multiple events can come in while they're active, and then at some point, once some other event happens, the gesture becomes inactive. But for discrete events like long press and tap, what happens is that as soon as it becomes active, it immediately transitions to ended. And the reason why we're able to still have began with tap gesture handler and we don't have it with long press gesture handler is that tap gesture handler is actually implemented on top of pan, the pan gesture natively, whereas long press isn't. And there are some reasons for why that is. But essentially, just all you have to know is that there isn't a began state for long press gesture handler. So again, you can do this on your own. I'm going to just do it up here, and you can follow along if you feel like, or do it on your laptop. Let's open this up.
Is there like a shorthand to define, say, this top and all the sides, or you need to define like top, bottom, left, right?
I think you have to define top, bottom. Yeah, maybe there is. Actually, I'm not sure. So all I did here was import long press gesture handler, change tap to long press, remove the, I think I had a number of taps there. Didn't need that anymore. And touch began. We don't actually have this, so we can rename the state to touch active if we want. But it's not going to be particularly useful in this case because it transitions from active to ended almost immediately. So if we actually want to make this look like something is happening, we probably want to use an animated value here and fade in the, or fade out the opacity and fade it back in afterwards. I'm not going to bother with that here, but you're welcome to look at an example of doing this in the animations and gestures repository that I shared. And inside here, we don't need state began. Really all we care about here is, well, I could say, let's just do that for fun. And so let's position this a little bit lower so we can actually see something happening. Padding top, actually, yeah, padding top, 100. No. 100. Actually, that didn't touch active true. Oh, I got rid of that, right. Touch active. Let's just do that. Touch active 0.11. There we go. So if we do alert, and we can change the time it takes by doing min duration ms. Change it to 2 seconds if we want. So that took a while. All right. So it's pretty straightforward, quite simple. It's not much different from tap gesture handler. And the next thing that's worth looking at is how we can combine these two gestures so we can use them both in one place. And so we can have the tap recognize on the same view that long press can recognize on. And I'm going to not demonstrate this one right now because I want people to try it out on their own. But just as a hint, you can compose gestures just like you compose regular components in React Native. So you can put tap inside of a long press or put long press inside of tap. And that will allow you to perform one of these gestures. So let's take 5 minutes and just try and do that one. Okay, let's have a look at how to do this. Jump back to this other one. Oh, actually, this is fine. Okay, so just working with this example of having long press, I'm going to say tap or long press. And once again, I have to have tap gesture handler. And what I can do now is just wrap the long press gesture handler with a tap gesture handler. And for convenience here, I'm going to use this called onActivated. So that's just fired whenever we switch from whatever state to activated. And in this case, I'm just going to say tapped. And we'll leave that as is. So if I long press, actually let's change that from high to long press so it's more clear. Right, so if I tap on it, it says tapped. If I long press, it says long press. Any questions about that? Yep.
Were using the same event handler with different gestures.
Right.
Could you distinguish which one?
I mean, you could, but not. So the question was, if you're using the same event handler for multiple gestures, so the same callback to on handler state change, could you distinguish between what gesture it's coming from? And like you could, but not in, like practically speaking. Like you could take the target and find out what component that belongs to. And actually no, because they would be pointing to the same thing, I believe. So no, not practically. You should use different callbacks for that. So yeah, I would make a different one. This one would be like on long press state change and the other one on tap state change. Just for convenience here, I just used on activated. But of course, if you actually wanted to add the like some effect to the view when you tap on it, so like change the opacity and whatnot, you'd probably want to use handler state change.
How do you change the, like, say, opacity on the long press because it doesn't have begin?
You just do it on active. So the question was, how do you change the opacity on long press? The only way to do that is on active. So yeah, when it becomes active, like, so I can get rid of this alert, and I long press, and now it goes there, and then I release, and it's gone.
Is there any considerations when you're mixing like gesture handlers like this, like from the general gesture to the more particular gesture, or what are the thoughts about that?
So the question was, when you're nesting gesture handlers like this, are there any concerns about, like, do you go from a more general to a more specific gesture? We'll look more at how you can control this a bit later. There's some properties that let you specify, like simultaneous handler, and specify the ID for it. So yeah, no, we'll look more at that a little bit later. So what we've done here can actually be accomplished usually more easily using some built-in button components. In the gesture handler repository, or rather the gesture and animations repository, on the, I think it's the tap tab, there are examples of using this thing called Rect Button. And a Rect Button is basically like very similar to touchable highlight and touchable native feedback. So on Android, it uses the ripple, and it keeps the material ripple effect within the bounds of the button. Borderless button, you'd usually use it on something like icons or text, where you want the ripple on Android to expand beyond its own bounds. And on iOS, it's typically used for the same situation, but the effect on iOS that you usually go for in this case is to change the opacity. So it's similar to touchable opacity. So yeah, you typically don't use tap and long press for like most of your buttons in your app. There might be cases where it will be useful, but typically we'll be using Rect Button for things with backgrounds and Borderless Button for things with text and icons. Like I said, they both add material ripple effect. And then there's another thing called Base Button, which you can use if you don't want the visual effects that are provided by Rect Button and Borderless Button. And it kind of just handles the gesture state change logic for you, and you can kind of specify how it should style itself in response to that. And you can check out the documentation for that if you are curious. So I'm going to move on to the pan gesture. This is an area where I think this really gets super interesting because, as I mentioned before, we're able to use the native driver and animated event to handle this entire gesture on the UI thread and not be bound to having to call back into the JavaScript thread at all. And so what we're actually doing here, like the JavaScript thread could be running at 0 frames per second, could be entirely blocked, and we're still able to move this box around, just like we're still able to scroll within a scroll view. And so it allows you to build these like really performant gestures that you wouldn't be able to otherwise. So pan gesture handler looks a lot like tap gesture handler. We have pan gesture handler with an on gesture event. We get an event object with a native event property, and if we just use console.log there and have a look at the different values that are exposed from that, the ones that are typically the most frequently used are the translation X and the translation Y. There's some other ones like velocity X, velocity Y, which can be particularly useful. Also, of course, the old state and state are useful as well. Actually, let's jump ahead a little bit. So it's worth, I think, looking at the difference between the absolute X and translation, velocity, et cetera, at this point. So the translation X is the distance moved from the initial touch. So when the gesture recognizes and you start moving, it starts at 0. The translation X and the translation Y starts from 0 from there, and then as you start moving your finger, that changes depending on where the initial touch was. The absolute X and Y is where your touch is relative to the entire screen, where the top left is 0, 0, and the bottom right is whatever the width and height is of your screen. The velocity, X and Y, is the velocity in points per second. So if we started our touch at the very top left of the screen and moved it 100 points to the right over 1 second, then the velocity would be 100. It would be positive 100. And it would be negative if we started at 100 and moved it back to 0 over a second. And the X and Y is the position of the touch relative to the view. So we have, in the video of the pan gesture we were showing before, you can touch anywhere inside of that box, but you might want to know, am I touching the top left of the box? Am I touching the bottom right of the box? Or where within the box is this gesture currently occurring at? And that's not usually super useful, but it's there in case you need it. So let's go back here, and let's build this. So I want to build something like that. As I mentioned, we are most interested here in the translation X and translation Y. I underlined this because the transform property is called translate X and translate Y, but the property on the event is called translation Y and translation X. I'm not actually sure what the reason is for that discrepancy, but either way, it's worth noting. And so essentially what we need to do here, let's not use animated event for now. Let's just handle the gesture event. Oh, sorry, I didn't actually mention this one. That's definitely very important to mention. So on gesture event is different from what we've seen before, my bad. We'd previously seen on handler state change, right? Handler state going from one state of the handler to another. But once the handler is active, when you have a continuous gesture, like a pan, where you enter active and then you move your finger around, and there are gesture events firing every frame that you move your finger. The way to receive those events, because the handler state isn't changing, it's still active, it stays in the active state, but you care about the events that are coming in. And so this onGesture event prop allows you to handle those events. And that's all we really need to care about at this point. We can actually, right now, not pay attention to handler state change, but that actually, it is important. We'll see it in a bit, but for now, for the sake of just demonstrating this, let's use onGesture event, and we take that native event, and we're going to set some animated value for the to position this box somewhere on the screen using the translate X and translate Y transforms, which come from translation X and translation Y. Any questions before I take a few minutes to work on this? Give people a few minutes, and then I'll demonstrate it up here. Sorry, which? Oh, sure, yeah. Okay, let's have a look at how to do this. Okay, so what I've just set up so far is I have this animated view. It's just positioned using align items and justify content to be in the center of the screen. And I didn't add a gesture handler yet, but that's the first thing we are going to do. So let's get pan gesture handler. Oh, good typing. And we can wrap the animated view with pan gesture handler. So just to clarify this, if we had made the pan gesture handler around the entire view containing the entire app, this pan gesture would apply to the whole app, right? It would be, the whole screen would be the pan gesture. It's just worth noting, I noticed someone had an issue where they wrapped a tap gesture handler or wrapped an entire view with the tap gesture handler. And so it's just going to, like these touch events will be captured for whatever view is the child of the handler. So in this case, we only want to be able to drag this by dragging the box. If we wanted to make it so we could drag here and the box would move, then we would just have to move this pan gesture handler to the outside. So I'm now going to add on gesture events. And I'm just going to set handle pan event. So let's destructure the native event from there. And we know that we care about the translation X and translation Y. And then we need to do something with that. So some people took the approach of doing set state. You can do that, but it's going to be quite slow because you have to, so you have to set state every time the gesture event happens, and that's kind of like how, I don't know if any of you used React tween state before, but it was a similar sort of thing when you wanted to do an animation, it would set state and update every time. But with animated, it basically gives us a more optimized way to do that. Right? Instead of doing set state, it will call set native props and update these things without actually doing reconciliation. So we're going to instead use, let's call it panx. We're going to use an animated value for each of these. And of course, later, as I mentioned, using native driver, you can't use native driver and update state values. You need to, unless it's an animated value that's stored on state, but ultimately native driver is something that is an animated concept. And so in order to use native driver, we need to use animated values. So we're not doing that currently though, we will momentarily. So we have pan X, pan Y, and now we can just do this.panx.setValue, translation X, and this.pany.setValue. Right, and now translate X equals, we can just say this.panx, translate Y, this.pany, and transform. So nothing new here. Translate X, translate Y. Format that so we can read it. Right, so we have these values, animated values, pan X, pan Y. When a gesture event happens, we take the translation X, translation Y off of this native event, and then we just update the animated values, pan X and pan Y, just setting the value directly on it using the incoming value from the event. So if I drag this, it follows as I move my finger. And something that people noticed that I guess if I didn't explain this to you, or if I did explain it to you, don't answer the question, but if I didn't explain it to you, I'm curious if people can guess what is happening here. So now that I release this gesture, and then I start dragging it again, right, it goes back to the middle of the screen where it was originally. So can anyone guess why that's happening? Yeah, so it's because the translation resets from 0 when you start dragging it, right? The translation X and the translation Y for the pan event they start at 0 for every pan event. So when I start dragging here, it's not retaining some value of like, you previously dragged 100 points down and 50 points to the left, and so now the translation is going to be that plus whatever you've moved. It's relative to where you start the gesture, and it starts at 0 every time. So, of course, that's not really desirable, and we'll look at how to fix that. Yeah. So the question was, should we keep the final position on the state when the gesture ends? And that's pretty close to what we're going to do. It's a common problem that you encounter, and so animated gives you a solution for how to deal with this. And it's something called offsets. Because basically that's exactly the point, is that we need to be accumulating these values. We can't reset every time. We want to, when this 0 or like this translation X of some amount and translation Y comes in, we want to add that to what we had previously. And so we can use this concept of offsets in animated to do that. So we've so far just thought of animated values as, like, if we set it to 0, the value is 0. If we set it to 1, the value is 1. And the wording here is like kind of strange because we actually calculate the value by taking the value and adding an offset. And so this code is from the internal implementation of animated. So get value takes the value and adds the offset. And then there's something called extract offset, which adds the current value to the offset and resets the value to 0. So it doesn't actually change what the result of like getting the value is, because that's the sum of the value and the offset, but it just shuffles around where the components of the value are stored, right? It takes the internal representation of the value and moves it into the offset, and then the value is still ultimately the same. And so this is exactly what we need to do in this case, because when we reset the translation Y and translation X to 0 when we start the next gesture, we want that to be like, we're calling set value on this, and so it'll be that value plus whatever the offset is so far. And yeah, so this is pretty much the solution for how to handle that. So the way that we would do that is when we transition from active to any state, we need to take the animated value and call extract offset on each of those. And so again, that takes the current value. I wish I had better words for this. If you have suggestions for how to phrase this better, let me know. But it takes the let's say underscore value, and it takes that and it resets it to 0, and the underscore value that it's set to at the time is added to the offset. The offset, of course, starts at 0. So this allows us to basically handle this situation so that next time when we start the translation again, it is just added to what the previous value was, and it makes it possible to accumulate values over time in animated. So that's good. So I'm not going to make people do that right now. I'll just demonstrate how to do it since we've just seen the code right there. So let's open this up. So again, right now I'm dragging. I start dragging again, resets. Just to demonstrate again that this goes to 0, 0. If I remove any layout that comes from the parent, it's going to be at the top left, right? 0, 0. I start dragging, go again. Now it's again jumps back to 0, 0. So let's add on handler state change. We need to have access to the state object, and we can say if native event.old state. Because we really only care when you transition from active to anything. That's when we go, okay, the gesture's done. We don't care if it was canceled or whatever. We just want to store whatever the value was at that time in the offset. So this .panx.extract offset. Oops, extract. Right, and now it resumes from where we were before. And save that. Share it there. So what we've seen there is basically how you perform an action when the gesture has completed, right? Like we are responding to the gesture finishing by transitioning from active to another state and taking that opportunity that we know the gesture has ended to extract the offset so that it's ready next time the gesture starts. But if there are frequently many other things that you might want to do when the gesture ends. You might want to animate it to some other position, right? In the case of a modal, you kind of have to decide, has the user moved the modal far enough that I want to animate it out and dismiss the modal, or do I want to reset it back to its original position? Or if you have something like a list view where you can swipe rows open, do I want to open or like reveal the underlying buttons, or do I want to close the button, or rather hide the buttons by kind of translating the view on top again back to its original position? In the case of like Tinder, do I want to, fling the card off to the side and follow through on the gesture? And so these are all sorts of things that you might do when a gesture ends. And it's valuable in this case to know various aspects of the gesture, like what is the velocity of the gesture, because maybe you've only moved, maybe you've only translated the modal 50 points down, but maybe you did that over 1/10 of a second, so you just flinged it really quickly down. In that case, it would be kind of weird if it just bounced back to the original position. That probably shows intent by the user that they have intended to dismiss this. And so you look at some combination, usually of like velocity and translation, to determine whether sufficient intent can be established that the user wants to do whatever action that they might do with the gesture. And again, these are what these mean. I'll just paste these in the Slack channel in a moment. And now we're going to take this modal that we did before, and we want to make it dismissible. So using a gesture. Previously what we did, right, was press the close button, and then that would just close it. But what if you want to dismiss it like in the example app Qua, where we can swipe it up and down and release it, and then it goes off the screen and closes the modal, which is, these are very common interactions that you'd like to have in mobile apps often. And so, yeah, let's take that and build this. It's pretty good timing because I think this might be a little bit difficult, and so maybe over lunch, you have the Qua app there you can look at as an example. There's also within the animation and gesture repository another example of doing this. So those are things you can refer to and just try and get it working on your own. And let me know if you have any questions. I'll probably be back around here at 12:30 if you can't figure it out in the next 10 minutes, because I guess it's about 10 minutes to noon. So yeah, let's get started on that, and I'll just walk around and help you out. And I'll paste this. Sorry?
Did you come over when you had time?
Yeah, yeah, sure. So this is what the example looks like in the animations and gesture repository. Pretty bare bones on top of what we had before. So just try and recreate that, and it's definitely not cheating to just refer to that and try and understand what's happening. if you want to get first dibs on lunch, you can just go now also. I don't think anyone else has gone yet, so. Yeah. Okay, it's actually properly lunchtime now, so go grab your lunch. And yeah, I'll be here again at 12:30 if you want to ask more questions about this.